In this video, I'd like to talk about the math question of the day for March 24th, 2023. And with this problem, we need to find what the range is of this function f of x, this exponential function 2 to the x plus 3 power, and 1 is subtracted from that. So to answer a question like this, dealing with range or maybe even domain, you will need at least the tools of Algebra 1 and Algebra 2. Though since this is an exponential function where you will typically learn this in Algebra 2, you will probably need at a minimum the tools of Algebra 2, though a question like this might also be found or introduced in a pre-calculus class. So at this point, go ahead and pause the video, see if you can work through this on your own, and when you're ready, unpause the video and we can go through this together. Now, assuming that you have at least attempted the problem, let's start working through it. And if you do have suggestions for future questions of the day, feel free to leave those as comments. Now, when finding domain and range, we need to first remember what their definitions are. And for the domain deals with the independent variable. It deals with the x values that you can actually plug into our function. Or another way to look at it is that the domain asks the question, which x values can be graphed? And I should be specific. We are graphing these on the standard xy coordinate plane. So if it cannot be graphed on this plane, then we would say it's not in the domain. Though that is more of a high school definition. When you advance in mathematics and you allow the independent variable to take on imaginary numbers, then that definition doesn't quite work as well. But for a high school definition, this works perfectly well. A more general definition is just that the domain is the set of all x values that can be plugged into the function. Now with the range, it's very similar, but it deals with the y values. The range just asks which y values can be graphed. And the simple truth is that the range is much harder to find since you need to know what the picture actually looks like. For the domain, you're really just looking at two main issues. Are you dividing by 0 or are you looking at square roots? Since you can never divide by 0, so that can't be a part of the domain. And with square roots of negative numbers, you can't plot those on the standard xy plane. So domain just deals with these two issues, which you can figure out by looking at the equation. In fact, in this case, we don't have division by 0 and we don't have square roots. So we can actually conclude that our domain is the set of all real numbers, which we can just write using this symbol, which again just means the set of all real numbers. It's all of the numbers that are on the number line, not including complex numbers. So we're not extending that to the complex plane. This is just the set of all real numbers on that number line. But with the range, it's not that simple. We can't just look at the equation. We actually need to know what the picture looks like to figure out what the lowest possible y value is and what the highest possible y value is. So to construct a picture of this, a graph, there are two main approaches. We can create a table, pick different values of x and y, plug them in, plot those points, and then draw a curve. Or we can start with the parent function here, and the parent function in this case is just 2 to the x, and then just realize that this function was shifted. In fact, we are adding 3 to this independent variable, which tells us that we are shifting the parent function to the left 3 units. And remember, with dealing with the inside and the independent variable, it's always the opposite of what you might expect. Even though we're adding 3, we actually go left 3. And one way to think about that is you can ask yourself which x value makes this expression 0. And that would be negative 3. And that tells you to go in the negative direction 3 units. But when dealing with the outside, it's more straightforward. we are subtracting 1, or in other words, we are subtracting 1 from all of the y values in the parent function, so that shifts everything down 1 unit. So we start with our parent function. Let me draw a coordinate plane here. And with our parent function, which we can do in this blue color here, if we plot points, we can construct this quickly. But if you plug in 0, you get 1. Anything to the 0 power is 1. If you plug in 1, you get 2. If you plug in 2, you get 4. And if you plug in -1, we are dividing by 2 once, which is 1/2. -2 means we're dividing by 2 twice, which is 1/4. -3 would be 1/8, and so on. But we can now construct the general shape of the curve. It will essentially hug along this x-axis, and then will rise very quickly after that, since exponential functions will shoot up very fast as the x value gets bigger and bigger. But like I mentioned, it will hug this curve as the x values get more and more negative, since the x-axis for the parent function is an asymptote. It's a boundary that the function will not cross. It is impossible to get a negative y value out of this when you're plugging in real numbers for your x values. So we have this parent function graphed in blue, but our function here, which we can do in this pink color, we know is just that parent function, but shifted down 1 and to the left 3. So when shifting down 1, we are really just shifting that asymptote. So let me draw in that boundary layer there. The function won't cross that. And we'll shift everything to the left 3 units. Let's look at this point right here. This is a key point, since on our parent function, that is an x value of 0 and a y value of 1. So we shift that point down 1 and 3 to the left. So it will now be right there. Whereas this point right here, we can shift another one at 1, 2. We'll shift down 1 and 3 to the left. In fact, all points will follow that pattern. This one right here shifts down 1 and 3 to the left. It will be right there. This point right here at -1, 1/2 will shift down 1 to -1/2 and then 3 to the left, right about there. So let me quickly draw in that curve. And if I drew this perfectly, you would see that it's the exact same curve. We didn't change the shape of it, we just shifted it around. If we wanted to change the shape, we would need to include multiplication. We could maybe multiply by 4 on the outside, or maybe by 5 on the inside. But we didn't have multiplication, meaning that we did not scale the function, we just shifted it around. But at this point, now that we have this picture of this pink curve, that's our function f of x, we can ask ourselves what the range is. Which y values are actually a part of this graph? And we can start by looking at what the lowest possible y value is. Notice we have this asymptote at a y value of -1. Like I said, this is our asymptote, that boundary layer that the function won't cross. So this is the lowest possible y value. But you need to be careful, because that exact y value at -1 is not actually included. It's not possible for this function to equal -1, just like it's not possible for this function to equal 0 when using real numbers as the inputs. So the lowest possible y value is just slightly above -1. Or when writing in our range, we can say that our y value has to be bigger than -1, but it can't equal -1. And then the y values just get bigger and bigger. In fact, they are going to shoot off to positive infinity. So y is always less than infinity. And of course, y can't equal infinity, because infinity is not a number, it is a concept. Now, we could also use a different notation. We can use interval notation. We use parentheses when the point is not included, when we don't have the equal sign. We put -1, that's the lowest value, and it goes to the highest value, which is infinity. And again, we'll use parentheses because we don't include that point. And if this value of -1 was included, we would just use a bracket instead. But we use parentheses because it's just greater than, not greater than or equal to. So this right here will be our final answer. You can use either this inequality notation or this interval notation. And if you want to check your work, I encourage you to plot this on some type of graphing calculator or using the website Desmos and confirm this for yourself. Look for the lowest possible y value and then think about what the highest y value is, and that will tell you what the range is.